Welcome to Make Made Simple. Today we will be studying about equivalent couples second part. So I have drawn a rigid body here and a couple is acting on it, F1 and F minus F1. So by principle of transmissibility, we can we can translate these two vectors forward. So I'll translate this vector to here. And for simplicity, I'll name it F2 vector. F2 vector. And similarly, this will be translated here. And this will be called minus F2 vector. Minus F2 vector. So I have translated the two vectors forward. Now let's join the two vectors tails together. So I've joined the two vectors tails together. Now I'll resolve this F2 vector into two components. One would be along this direction, that is F2 parallel, and one would be along this direction, that would be F2 perpendicular. Similarly, I'll resolve this into two components. Minus F2 parallel minus F2 parallel and minus F2 perpendicular. Minus F2 perpendicular. So that's how I have resolved two vectors. Now the distance between F and minus F was D. This was D. D1, and this from here point this to this. I'll name the vectors. This is point A, this is point B, this is point C, and this is point D. CD vector is equals to CD, the distance between C and D will be D2. So that's how the D2 has come. Now moment when, that is F1 vector and minus F1 vector, what will be the moment caused by that? That will be equal to moment 1 vector magnitude equals D1F. And if we see here, this vector F minus F2 parallel and F2 parallel will will have a same direction along this direction and along this direction. So these will not contribute to the moment for the rigid body. Only minus F2 perpendicular and F2 perpendicular will have a moment that will cause the body to rotate. So we have m1 vector is equals to d1 f1, and similarly we will have f1 d1 equals f2 perpendicular d2. So f1 d1 will be equal to f2 d2. So as they these vectors as they go farther apart, these components will become smaller and smaller, and this distance will become bigger and bigger. This d2 will become bigger and bigger, and the moment that f1 d1 has will be same as the moment f2 perpendicular d2. So that's how we see that the moment is same as these two vectors will, when I separate them farther apart, they will create the same moment as f1 and minus f1. So that's all for today. Thank you guys for listening. If you have gained some knowledge from this video, please do like the video, subscribe to my channel and share it among your friends. Thank you.